that I've said this. So the way the semester test is going to work is that regardless of whether it is your week or not your week to come to campus, everyone is going to come and write the semester test. Okay. And so we're going to make use of all the computer labs. We're going to use the computer science computer labs. We're going to use the informatics computer labs. We've even booked a computer lab by D Lab. Okay, but don't worry, that's not your concern. Your concern is getting your behind to the venue, all right, on that last Friday. So that last Friday of the semester, you have to be there. Okay? We will tell you which lab to go to. But what we will do is we will assign you a computer number. So prior to maybe by Friday morning, you will check on Eve, log into Eve, go to Marks, and under Marks, you will see that there is next to something called Semester Test 2 PC number, you will see your computer number. Okay, so you will be assigned a computer number. So the twin sisters don't get to sit next to each other. All right, but the idea is you will be given a computer number. And sorry, let me just cancel. I don't know why people want to call me when I'm busy. Okay, I hate Teams for that. I know you guys are not there yet, but when you get into Microsoft 365 and all that environment, everyone just loves to make use of all the tools. Okay, so with that, you will rock up. Now, here's what you're not allowed to bring to the venue with you. You cannot bring any USB storage devices with you, okay? You're not allowed to bring any notes with you. No paper, right? We will, when you get in and you sit down at your computer number, because we'll number the computers and you sit at the computer you've been assigned, and you will have in front of you a question paper as well as test paper, like from semester test 1, and you're going to use that test paper for the first 20 minutes to do your design using pen and paper. Well, paper is given to you, bring your own pen. Okay, so you do your design for the first 20 minutes. You do not type anything on a computer, no touchy on a computer. Just do your design. We're forcing you to read the question and answer, write down your plan for writing the code. Then 20 minutes are up, we will tell you, right, you may begin programming. So for the rest of the 2 hours and 40 minutes, you can tap away, program, etc. Now, during this time, if you really need to go to the bathroom, you can put your hand up and we will escort you to the bathroom. Escort you. So you don't just go, oh, I'm going to the bathroom and run out. You run out, bye-bye, see you next year. Okay. Do you really want to go to the bathroom? Well, if you really have to, sure. But my advice to you is please go to the bathroom beforehand and then use that full 3 hours, because you're not going to go, oh, I need to go to the bathroom, and then we go, oh, you took 10 minutes to go to the bathroom, you get an extra 10 minutes. No, none of that. So if you want to use bathroom all the time repeatedly, then you're wasting your own 3 hours. Okay, so 3 hours to complete the entire test. Once the 3 hours up, we're going to tell you to stop typing everything, save your work, and we upload to Eve like you would upload for a normal practical. And then we will mark it. Now, obviously, because it's the last day of the semester, you're going to have to give us time to mark your semester test as quickly as possible, okay? And please note that the week after is block week, so all our assistants who are allowed to mark have to study for their honors semester test. So guess who's marking most of the semester test? Mr. Levier and myself. So do you want us to be grumpy? Do you want us to have to look for your code? No, you want to just roll out the code and say, here's all the answers. Yeah. Just give us the marks. And here we go, yes, we see everything. And then we give you marks. So that's why we are urging you, please, to write the code in a clear way that we can find things. That's why we've been asking you, please do that. Okay, right. Anyway, that's the thing. You're not allowed to bring your own laptops. People are, oh, these spoiled people. You have to use the computers in the labs. Okay, no excuses. Look, if there's a network issue, then we will be aware of it and we'll accommodate for extra time and so on, as necessary. However, power goes out and you have not been saving your work for the last 2.5 hours, are we going to give you an extra 2.5 hours to go and work on it again? No. It is your responsibility to save and save to the correct location. Where do you save to? In the computer labs. On the T drive and only to the T drive. Is that clear? Okay. All right. So, yes, you have to do the design in the first 20 minutes. That's what I've been saying. Okay, so let's actually go and into the topic of today's lecture, which is to explain to you what we kind of described already yesterday. Well, I didn't. I wasn't involved. I had Prof. Underhart take my place to give the lecture. I don't know whose class you were in. Were you in Mr. Labier's or Prof. Underhart's? But the point is, yesterday they finished off lecture 18, which was to do with the introduction of working with a problem relating to record structures. So by now, today, hopefully, even if you don't understand how to find a minimum or maximum in anything, that's okay. We'll go through it in greater detail today. But by today, you need to understand the concept of, number one, defining a record structure. Number two, knowing how to allocate space in memory for these record structures. And number three, how to actually use it. And the way you use it is pretty much like how you would use any control on in a Windows form. So if you want to refer to the text property of a text box, you would go .text. If you want to refer to the row or the column or the text of a UJ grid, you would go the name of the grid, dot, so and so. Same thing happening with your record structures. Are you on that page? Okay, so let's go and talk about finding a minimum or maximum. All right, so the checklist for today really is, how do you find a maximum or a minimum? Because it's the same idea, it's the same principle. The only difference really is the direction of your greater than sign. Okay, obviously when I say that, that means the other side is a greater than or a less than sign. That's effectively it. And some clever minds are going to go, wait, hang on. What happens if I have an array, and that array contains two values that happen to be the same, maximum value? So in an array, you've got two people, we've got 100. What happens then? In the real world, you would have to deal with it. In Informatics 1A world, where you're just starting to program, we assume the following. Either there will only be one maximum or one minimum, or if there is multiple maximums that are the same, you don't worry about it. You only worry about the first one. Okay, does that make sense? All right. Okay, so over here, today we're just going to go through how do we find a maximum or minimum among multiple values. In other words, there are multiple variables containing values, and you want to do a comparison to see which one has the biggest value or which one has the smallest value. Now, if you do it with single variables, which is what you've been doing for your practicals, yes, it is messy, isn't it? Did anyone go, yes, it's easy to solve, but I would prefer not to have to write the code for that again? Who feels that one? Hands up. Is it because we didn't give you enough single variables? What if you had 10 single variables? Who's going to feel, yeah, I prefer not to? Right, okay. And then we're going to look at a fixed size array and then a dynamic array. And then the more important thing is, how do we find multiple minimums or maximums? Because that's what actually happened in the question yesterday. Have you noticed? You weren't asked to just find one maximum or one minimum. You had to find multiple. Or was it actually just one? Not sure. Okay, okay, but for the semester test, you will be required to find multiple. Okay, there's a possibility that you have to find multiple maximums, or you might be required to find just one. It depends. So to give you an example of where would I ask you to find multiple maximums is going back to our student record structure question. All right, if I ask you which student has the highest average, how many maximums am I looking for? One or multiple? If I go which student has the highest score? It's just one. You're looking for one student with a higher score, right? But if I said, for each student, what is your highest score? That's obvious, right? Then it's multiple answers, because then every student here gets their maximum value displayed. Does this make sense? And we're interested in finding that, but we're also interested in you being able to tell us of everyone in the room who has the highest score. Okay, and what is the difference? Is there a big difference in terms of finding a maximum, whether it is each of you, what is your highest score? And in the whole lot of you, who has the highest score? The way to find the maximum or a minimum is exactly the same principle. What differs is where you look and how many times you look. Does that make sense? Okay, so let's look at what we're doing. Right, so when you're working with single variables, so here's an example. Consider 3 values which store integer values. There are 2 possible ways in which the question is asked. What is the maximum and which is the maximum? And this actually is a question that will be pertinent to every possible question containing finding a minimum, finding a maximum. I could ask you, what is the maximum? But I can also ask you, which of the many records contains the maximum? Okay, so same question with me asking the question. I said, what is the highest score in the first semester test? Right? But I can also ask, who had the highest score in the first semester test? See the difference between the two? Okay. Right, so the solution for finding out if you have 3 values, which one has the maximum, you all know that the code looks pretty much like this. So you would have to, because it's single variables, you would have to write a whole bunch of if statements where you go, if the one value is greater than all the other values, then this value happens to be the maximum. But if the other variable is greater than all the other variables, then this one is the maximum. Can you see why, if you had to work with single variables, finding a maximum minimum really sucks? Because this is easy. This is just 3 variables. But if you had 10 variables, that would be 10 sets of if statements. And each if statement would be if variable 1 is greater than variable 2, and variable 1 is greater than variable 3, and variable 1 is greater than variable 4, and so on. I'm not going to go there. But you all know what I'm talking about. That sucks. You don't want that. And thankfully, we don't hate you that much. Because don't bother with this. We're not going to do this. So you're like, yay. Thankfully. So let's not worry too much about that. Let's consider this arrays problem, because that's the one you're dealing with. Now, if you take a look at, sorry, let me go back one slide. If you look at this variable, this array, okay, it's a variable, you agree? It's in a variable of a fixed size array. There are 7 elements in this array, and we can look at it. Now, the top row is basically which number it is, which element it is. The bottom one is the values itself. Now, if I ask you, oh, hey, which one is the maximum? You're all going to be able to go, I can tell you the answer, right? Because you looked, and you told me. So if I tell you, okay, no. Don't just do that. Don't just look and tell me. Tell me how you know. What did you have to do to be able to get this answer that you can tell me? And you can't just go, I saw everything. Okay, in a way, you're telling me you saw everything. You looked at all the numbers and then you made a decision. Great. That's true. That's really important because it contributes to how we tell the computer how to find a maximum. Okay. So it's a bit like a running competition. So imagine you've got all these people running in a race and we're trying to figure out, well, who's the fastest? All right. Can we just go, let's look at everyone in the class, everyone online. Who's the fastest in this class? Can you tell me? No? Why not? How are you going to be able to determine who's the fastest? By comparing, right? So what do we ask you all to do? You ask you all, let's go outside. We're going to tell you, run this racetrack, and we're going to time you, right? We're going to time everyone. We're going to look at everyone's time. That is important. Okay, so you start with an official default minimum. Okay, because in this one, obviously, if we're trying to figure out who's the fastest, then we're looking for a minimum, not a maximum. I mean, if we're going maximum, I win. I'm going to volunteer myself. I'm the slowest in this class. Or is anyone going to fight me for that title? I don't know. All right? But the point is, we're going to try and figure out who's the minimum. So in other words, who will take the least amount of time to get through this lab? But do we have something to work with? In other words, do we have an idea of what we consider to be a benchmark to work with the rest of everyone who's taking part in this competition? No. All right? Some of you might go, can't we set it to 0? Right, that makes sense. Why don't we just set it to 0? And if we have 0, then we compare everything else with 0. Now that works okay for a competition like this, but is that a good algorithm? No. Okay, the best way to do it is actually to set the first person or the first entry point or the first element in your array as your point of reference. Okay. So let's say this person said, oh, they took 242 seconds to do this lap or whatever. Then you're going to tell us that the minimum to start off with is 242. All right. And then you're going to use it and you're going to say, right, in our mind, the minimum is 242, and we're going to compare everybody else we are looking at. All right. So if there were so many people who took part in this competition, we start off with the first person, we take that person and we say that person's value will be our reference as the minimum, the starting minimum. And then we're going to compare it with everybody else. So we're not going to look at the first person again. Is there a point to look at the first person again? No, because we already looked at them. We use them as the benchmark. We say starting point, the minimum is 242. Now we're going to look at everybody else and we're going to say, what are your times? So we look at the second person and they say, oh, they took 368 seconds. Right, and you're going to compare it. You're going to go, well, my minimum at the point is 242. Is it less than 368? No. So in other words, is this person faster than our known minimum so far? No. So do we need to update our minimum to say, woo, we found a new winner? No. So we leave it alone. Okay, we move on to the next person. And we go, hello, next person, how long did you take? Our minimum in our mind is 242 still. They say, oh, they only took 240 seconds. That's smaller than 242. So we update our minimum to 240, right? And then we use it to compare the rest of our people participating until the last person. And every time someone has a new value, has a value that is lower than our existing minimum, we update. Does this make sense? All right, so the algorithm. And this is only if we want to know what is the minimum or what is the maximum back to our example. Then you need to do the following. These are the steps. You basically set the default maximum to the first value. So you say, my default is whatever the first value in the element is. Okay, that's my default. Then you compare this maximum value with the rest of your array. So you go to 2 to 7 and you check. Do we have a new maximum? All right? Okay, apologies. Right. So if there is a bigger value, then you update your maximum. Now, if you want to know which one is the maximum, then you need to add these 2 extra lines of code. The first one is we just set the default of the maximum value. But if we need to know which one is also the maximum, we also have to have a second variable which keeps track of where is the maximum value. So we have a variable for what is the maximum value, but we also have a variable for where is the maximum value. And when it comes to when we find a new bigger number, we don't just update the maximum value, we also update the index to go, oh, this is where it is. This is where the new maximum is. All right. And would it be work to set the default max to 0? Remember, we talked about this earlier now. We said, no, that's bad. Okay. All right. And so code-wise, here is the example of our code. So you see that this is what maximum. In other words, we're only interested in knowing what is the maximum value. You see there on line 4, I start by saying maximum is equal to numbers 1. So the first element is my maximum. My for loop, notice that it starts from 2 to 7. Not 1 to 7, 2. Why not 1? Because if I use 1, then it means I'm looking at the first element again. Do I need to look at the first element? No. Okay. Then I have an if statement that checks to see if the maximum. So in other words, inside the for loop, I have an if statement. If statement is used to do the comparison. Is my current maximum less than the value I am looking at right now for comparison? If it's true that the maximum is smaller, it means that the value I'm looking at for comparison right now is a bigger number than we want. And so we want to update the maximum to this new maximum, which is the reason why on line 7, maximum is equal to numbers I, which is the current value I'm looking at. Does this make sense? Think back to the runners. Every time someone runs and is, yay, I took less time, we go, ooh, you, let's take your value. That will be our new minimum. If we want to update this to look for a minimum instead of maximum, how would we change this code? We would simply change the if statement of if maximum less than to if maximum is greater than. And I would change the variable maximum to minimum because, right? If you're going to write code and you tell me, I'm looking for a minimum, but the variable name is maximum, you're going to confuse me. Okay. Then I'll be like, huh? What are you doing? Okay. Okay, what is the value I? Well, the value I is basically used in our for loop. I is the index that's keeping track of our array. We start at 2, then 3, then 4, then 5, up to, in this case, 7. All right. Now, if I do want to go, which is the maximum? You'll notice there I've added 2 additional variables. Well, I've added 1 additional variable. And you'll see that on line 6 there, I update my maximum index to 1, which, as you know, that's my default value. That is where my maximum is right from the beginning. Decided that the first element is my reference point. It will be the starting maximum or starting minimum. Then I travel through the rest of the array and I go compare, 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 compare. What is your value? All right. So you can see that inside the if statement is just 1 additional extra line where I update not only the value to a maximum, but I also update the index to I, because I is the current element I am looking at. Does this make sense? Okay. So what if the array was dynamic? Is it really that much of a change smash if it's dynamic? No. What do I change to my code so now that, ooh, it's dynamic? Honestly, the principle is the same. So if you take a look at this code, what is the one difference I make here? My for loop changes. Have you noticed? Instead of saying that it ends at 7, because it doesn't, it now ends at the size of the array. Same thing. Oh, not even. I didn't even bother adding a new slide. You know, that's it. That's all we're changing. All right, ladies and gentlemen. And I see that some online people already say, yeah, num integers is what changes at the end. Okay, so that, ladies and gentlemen, is really how you find a minimum or a maximum in an array. Now, my suggestion to you is to please use this and practice. Implement it yourself, because it's one thing for me to go, yeah, talk, and tell you the algorithm and all that stuff. But you've got to implement it yourself. All right. Okay, yes, if you have any questions, you can ask me now. But otherwise than that, thank you, ladies and gentlemen. We are ending the lecture today. Right. Thank you. Goodbye. Hello? Yes, hi.